Hello everybody, and welcome to the supplementary handout for section 5.5. And this is just a couple of extra problems in practice using the integral tables we've been talking about. In this video, we're going to work through exercise 1 on this handout. Okay, so looking at this integral, it kind of looks intimidating at first. It's got the strange f of 3x's running around in it, but what we're going to see is it's exactly the same type of a problem as what we've been doing, just that we've got this unknown function f running around. Okay, and I want you to focus for a minute just on the denominator of this and notice that if we choose to let u be f of 3x, that's kind of a choice that will allow us to simplify the integral, that denominator looks like the general form a plus bu, okay, where a and b are 5 and 2. Let's try that substitution and just see where it leads us. Okay, if we do that, then we need to take the derivative of u. There we need to think back a little bit to calculus 1. How do you take the derivative of something that looks like f of 3x? Well, you're going to get f prime of 3x. But then the chain rule says that we need to multiply by 3 because the derivative of the 3x on the inside is 3. So we're going to get f prime of 3x times 3, put a dx on the end just like we always do, and then get the dx by itself by just dividing through by 3 times f prime of 3x. Okay, let's see if we can take that and rewrite our integral here. So, looking at the pieces, notice that there's an f of 3x that appears in a couple of places, so both of those are going to turn into u's. Okay, I'll leave the f prime of 3x alone for the time being here. Okay, and we just discovered that dx looks like du over 3f prime of 3x. Okay, do we get any cancellation here? Well, we do. We've got an f prime of 3x in the top and the bottom, so those go away entirely. And what's left is just, well, let's see, what can we do with this? I notice that there's a 3 in the denominator that we can factor out. Why don't we do that? Okay. Now, we sort of made the observation, or the choice at the beginning of the problem, to try to do a u substitution that gets our integral into this general form, a plus bu. So when we go to our integral tables, that's the part of the table that we're going to look at. All right, so let's find that grouping of formulas, a plus bu. Here it is. Okay, and in the bottom of our formula, we had a square root of 5 plus 2u. I'm just going to write that, otherwise I'm going to have a hard time remembering it. Do you see any table that looks promising? Okay, and actually I'm going to write the whole thing. We had a u over that. Okay, and if you look down to your table a little bit, formula 55 looks like the best match here. Okay, if we take that formula with a equals 5 and b equals 2, it tells us that our antiderivative should look like this. Okay, so we're going to go back and we're going to write down that antiderivative and fill in the a and the b that it gave us. Okay, so we're going to get 1/3. Okay, and then that formula tells us, let's see, we're going to get a 2 over 3 times 2 squared. And again, I'm just filling in the a and the b that formula is telling me to, times 2u minus 10 square root of 5 plus 2u. Okay, let's remind ourselves where that came from. That was formula 55 with a equals 5 and b equals 2. Okay, and the remainder of this is just kind of filling in the numbers and maybe doing a little simplifying if we can. So we've got a 1/3 in front. And in the brackets here, let's see. We've got a 2 over 3 times 2 squared. That's going to be a 2 over 3 times 4 is a 12. Okay, and then u is sitting over here, f of 3x. So everywhere we see a u, we're just going to put an f of 3x now. Okay, and that essentially is our answer. One thing that we could do maybe is to multiply these two fractions together. Okay, so 2 over 12 is really 1 over 6, and if we take that 1 over 6 and multiply it by a third, we're going to get 1 over 18. Okay, so as my final answer, I'm going to write it like this. 2f of 3x minus 10 times the square root of 5 plus 2f of 3x. Okay, so kind of an ugly looking answer, but we're using the same technique that we did before. The only difference is that we've got this unknown function f running around in our answer.